So we're going to look at shape of data. So as you saw, the data have different shapes. If we go back to that last problem, there was a definite shape to this data here. We saw that my variables increased and then they maxed out and then they started to decrease. This is what we're talking about, these kind of shapes. So these shapes are going to be important for us later. A histogram gives a visual impression of the shape of a data set. Statisticians have developed terminology to describe some of the commonly observed shapes that we end up seeing. So a histogram is skewed if one side is longer than the other side, or we say like the tail is longer. A histogram with a long tail to the right, like we have here. So my tail, here I have a right tail. If my tail is to the right, we end up saying this is skewed to the right. We're always skewed towards the tail. Because you're going in this direction and this direction is more positive, we call that positively skewed. If I have a histogram like this and my tail is to the left, then we call that skewed to the left. Remember, you always skew towards the tail. So if the tail is to the right and the skew is to the right. If the tail is to the left, then the skew is to the left. But in this case, because we're skewing to the left, my tail is down here, that's going in this way, which is a more negative direction. We will call that negatively skewed. So usually what this is representing is that when it's positively skewed, it means that we have large, very, very large data that really what they're going to be is outliers that are like way out there. Left skewed means we've got very small numbers if we only have a few of them and it's pulling everything in this direction. But the shape, so the other parts of the shape is we have symmetric. So symmetric, we're saying like parts of symmetric. So symmetric is if the right half is a mirror image of the left half. A few histograms are perfectly symmetric, so we just kind of eyeball them and go, yeah, they're approximately. We have two kinds of symmetric to think about. There's bell-shaped symmetric. There's more than this, but this is what we're focusing on. And that's like this. It's kind of got this domed bell shape to it. The other kind of symmetric is when we have everything's approximately the same frequency, and that is going to be uniform. This is the one we're going to care about the most. So when we go forward, what we're really looking at is bell-shaped symmetric data. There's different kinds of bell-shaped symmetric data, but we're specifically looking for what's called normally distributed data. And it's going to make these bell shapes. And like I said, it's not perfectly symmetric. It looks pretty symmetric, so we're going to say that it is. There's a little bit of this where it's going to be like you're just making your best guess. This one we can see is pretty uniform. Okay. We also have bimodal, or so unimodal and bimodal histograms. So what this means is that the data can be, like skewed or something like that, but what's important is how many bumps do we have in it, or we call modes. So a peak or a high point of a histogram is referred to as a mode. A histogram is unimodal, it only has one mode. So here we see one bump, one mode. If we have two bumps, it's bimodal. Past this, any more than that, like if we had data that had 3 bumps, if you had data with 4 bumps, 5 bumps going on and on, we call this multimodal. So it's either 1, 2, or it's several. That's how we usually label it. So we usually have we have just one name for one mode, a name for 2 modes, and anything past that, 3 modes, 4 modes, 5 modes, 100 modes, we just call that multimodal. Okay. So classify each of the following histograms as shaped Following histogram shapes as skewed to the left, skewed to the right, approximately bell shape, or approximately uniform. So we'll do the easy one first. This is definitely uniform. It makes a block. So uniform just means everything is equally likely to happen. This goes up and then it goes down, but it's pretty symmetric. So this one would be bell shaped. And then these two, it might go up and then it goes down, but as you see, it's not very symmetric. It's very much pulled to one side or the other. But because my tail is here on the right, this is going to be right or skewed to the right. And this one has its tail to the left. This one is going to be skewed to the left. I don't need to write that in there twice. Ones we're going to say if they're unimodal or bimodal. So sometimes that can be a little tricky. This one's pretty clearly unimodal. This one, you kind of got a little bump here, and then we got a big bump here, and you got like a little bump there. That's still hard to say. We kind of sort of smooth it out a little bit. Like if we have these tiny bumps, we sometimes just kind of ignore them. And like I said, it's argumentative, but I would probably look at that, like I said, as long as there are little bumps in it, looking at the big bump would say it's unimodal. And this one has two big bumps. And that one would be bimodal. So we want to know, try to describe this shape of this data with the spiders. So we kind of have like one bump here, and then it goes down, and then another bump here. You could argue that is bimodal data. Or you could argue that it is unimodal. And if you think it's unimodal, so what we'd be seeing there is that we think it looks kind of like it makes, let's get rid of some stuff here. If we're saying unimodal, then that means that we're kind of seeing like this kind of thing going on. There can be dependent on that. So you could say it looks like it's two bumps, you could say it looks like it's one. If it is unimodal, it definitely is going to be skewed. It's skewed. You definitely see it, there's a skewed relationship to it. This data is probably technically bimodal and kind of skewed to the right. So we usually see skewed right, skewed left, and symmetric in uniform, talking about just having one mode thing. Like I said, it just sort of depends how you look at it. If you think it has two modes, then it's bimodal. If you think it's unimodal, then it's probably skewed to the right.